In this video, we're going to look at Cambridge International AS Level Mathematics 9709, Pure Mathematics 1, Paper 1-2, from May-June 2025. Let's start with question 1. The diagram shows the graphs with equations y is equal to f of x and y is equal to g of x. Describe fully a sequence of two transformations which transforms the graph of y is equal to f of x to the graph of y is equal to g of x. Make clear the order in which the transformations should be applied. When considering transformations, we start with the stretch parallel to the x-axis, then the stretch parallel to the y-axis, and then any translation. Now, these graphs are drawn on a grid, so we can use the blocks to decide if the graph is stretched or not. Let's start with a stretch parallel to the x-axis. F of x lies at the top. It covers 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. Now we can see how many blocks g of x covers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Both graphs cover the same number of blocks horizontally, which means there is no stretch parallel to the x-axis. So now let's consider the stretch parallel to the y-axis. We can use the blocks and count the number of blocks that f of x covers vertically. 1, 2, 3. Now let's look at g of x. 1, 2, 3, 4, 5, 6. G of x is twice the height of f of x, which means that f of x has been stretched by a scale factor of 2. So for our first point in our answer, we can say that there is a stretch of scale factor 2 parallel to the y-axis. Now we can consider translation, movement up or down, or left or right. F of x has a y-intercept up here at 6. The corresponding part of g of x sits down here where y is -2. F of x has not moved horizontally. So now we need to look at a possible vertical shift. The y-intercept of f of x is 0, 6. And the stretch parallel to the y-axis affects the y-coordinate. So f of x, after a stretch with a scale factor of 2, should have a y-intercept at 12. But we can see that g of x has a y-intercept at -2, which means that f of x has shifted 14 units downwards. And for our second point for our answer, we can say that there is a translation of 0 and -14. Find the coordinates of the points of intersection of the curve and the line with equations 2xy plus 5y squared is equal to 24 and 2x plus y plus 4 is equal to 0. We need the x and y coordinates of the points of intersection. We have two unknown variables, so we need to use simultaneous equations. In the equation for the line, y is the only variable without a coefficient. So let's make it the subject. And we get y is equal to -2x minus 4. Now we can substitute -2x minus 4 into the y values of the curve. So we get 2x multiplied by -2x minus 4, close the bracket, plus 5, open bracket, minus 2x minus 4 squared is equal to 24. And now we have an equation that we can use to solve for x. So let's expand our brackets. 2x multiplied by negative 2x gives us negative 4x squared. 2x multiplied by negative 4 gives us negative 8x. Before I expand, I want to square this bracket. Negative 2x squared becomes positive 4x squared. Then I have negative 2x multiplied by negative 4 gives me positive 8x. Double it, and I get positive 16x. Negative 4 squared becomes positive 16. I can close the bracket, is equal to 24. Now I can expand. We have negative 4x squared minus 8x. 5 multiplied by 4 is 20, so we get plus 20x squared. 5 multiplied by 16 is 80, so we get plus 80x plus 80. We're working with a quadratic, and to solve for x, we need to make the equation equal to 0. So let's move 24 to the left. I have minus 24 is equal to 0. And now I can add like terms. Negative 4x squared plus 20x squared gives me 16x squared. I have negative 8x plus 80x gives me positive 72x. 80 minus 24 gives me positive 56. And this is all equal to 0. Now, in your exam, you do not have a lot of time. So the easiest way to solve for x is to use the quadratic formula, because you don't need to simplify your equation to use it. So we can use these values in this equation as they are. And we can say x is equal to negative b. B is 72. This becomes negative 72 plus or minus b squared, 72 squared, minus 4 multiplied by a, which is 16, multiplied by c, 56, all under square root, all over 2 multiplied by 16, which is 32. Now we can take our calculator and we can find the values under the root. We can say 72 squared minus 4 multiplied by 16 multiplied by 56 is equal to 1,600. Let's square root and we get 40. So now we can see that x is equal to negative 72 plus or minus 40 all over 32. Let's find x if there's a plus sign in the numerator. Take a calculator and we say negative 72 plus 40 divided by 32 is equal to negative 1. So x could be equal to negative 1. Now let's find x with a minus sign in the numerator. Negative 72 minus 40 divided by 32 is negative 7 over 2. These are the x coordinates of our points. And now we need to find the y coordinates. Earlier on, we rearranged the equation for the line and made y the subject. And we got y is equal to negative 2x minus 4. We can now use this equation to find the respective y coordinates. So let's find y when x is negative 1. So we can say y is equal to negative 2 multiplied by negative 1 minus 4. Negative 2 multiplied by negative 1 is positive 2. Minus 4 gives us negative 2. So the first point has coordinates negative 1, negative 2. Now let's find y when x is negative 7 over 2. And we can say y is equal to negative 2 multiplied by negative 7 over 2 minus 4. Negative 2 multiplied by negative 7 over 2. The negatives will cancel, the 2's will cancel, and we're left with 7 minus 4, which is equal to 3. So the coordinates of this point, negative 7 over 2 and positive 3. The coefficient of x to the 7 in the expansion of the bracket is 1280. Find the value of the constant p. When working with binomial expansion, we can use the formula NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. N is the exponent of the bracket, so in this case n is 5, a is the first term, px squared, and b is the second term, which in this case is 4 over px. To use the formula, we need the value of r. But remember that when you input values into NCR A and B, we're multiplying them together. And when you multiply variables with exponents, you can add the exponents. So let's consider the x variables in A and B. In A, we have x squared. So we're going to have x squared with an exponent of n minus r. In B, we simply have x. So we're going to multiply x with an exponent of r. And when we add like terms, we're going to get x with an exponent of 7. So let's expand our bracket. We have x. 2 multiplied by n is 2n minus 2r multiplied by x with an exponent of r is equal to x with an exponent of 7. Now our bases are the same, so we can add exponents. 2n minus 2r plus r is equal to 7. N is 5, so 2 multiplied by 5 gives us 10. Negative 2r plus r gives us negative r, and this is equal to 7, which means that 3 has to be equal to r. Now that we have r, we can fill our values into the formula. N is 5, so we can say 5c3 multiplied by px squared with an exponent of n minus r. 5 minus 3 gives us 2, multiplied by 4 over px with an exponent of 3. We need to find NCR. So let's take our calculator and we can say 5c3 is equal to 10. So this becomes 10 multiplied by p squared x with an exponent of 4 multiplied by 4 cubed is 64. So we get 64 over p with an exponent of 3 x cubed. Multiply these out. We have 10 multiplied by 64. So we get 640. P squared divided by p cubed gives us a fraction over p. X with an exponent of 4 multiplied by x cubed gives us x with an exponent of 7. And the question tells us that this is equal to 1280 x with an exponent of 7. And now I can solve for p. So I can say 640 over p is equal to 1280. Let's multiply both sides by p. I'm going to put this up here. 640 is equal to 1280 p. divide both sides by 1,280. I get 640 over 1,280 is equal to P. Now I can take my calculator and I can say 640 divided by 1,280 is equal to 1 over 2. So 1 over 2 is equal to P. A point P is moving along a curve with the equation y is equal to ax with an exponent of 3 over 2 minus 12x in such a way the x-coordinate of P is increasing at a constant rate of 5 units per second. Find the rate at which the y-coordinate of P is changing when x is equal to 9. Give your answer in terms of the constant a. When we are working with the rate of change, we need to use the chain rule. dy over dx is equal to dy over dt multiplied by dt over dx. The question tells us that the x-coordinate is increasing at a constant rate of 5 units. When we are working with rate, we use a fraction over dt. X is changing, so we can say dx over dt. The rate is 5, so this is equal to 5. The question asks us to find the rate at which the y-coordinate is changing. So we need to find dy over dt. To do this, we can use the chain rule, but we first need the value of dy over dx. We are given the equation for y, so let's find dy over dx. So we can say dy over dx is equal to 3 over 2 ax with an exponent of 1 over 2 minus 12. But we need an actual value for dy over dx. And the question tells us that the y-coordinate of P is changing when x is 9. So to find dy over dx, we substitute 9 into this x value over here. We're going to get 3 over 2 a. 9 with an exponent of 1 over 2 is the square root of 9. And when we are working with rate, we consider positive roots. So this is now 3 minus 12. 3 multiplied by 3 is 9. So we get 9 over 2a minus 12. This is our value for dy over dx. And now we can fill these into our formula. So instead of dy over dx, I'm going to say 9 over 2a minus 12 is equal to dy over dt, that's the value we need to find, multiplied by dt over dx. But we have dx over dt. So to find dt over dx, all we do is we change the rate into its reciprocal fraction. So dt over dx will be 1 over 5. And I can multiply this in over here. We want to find dy over dt. But to find out its value, we need it by itself on one side of the equal sign. So we need to move 1 over 5 to the left. Let's divide by 1 over 5, which means we're multiplying by 5. So on the left, I'm going to have 5, open bracket, 9 over 2a minus 12 is equal to dy over dt. Now I can expand the bracket, and I get 9 multiplied by 5, which is 45, over 2a minus 5 multiplied by 12, which is 60. This is the value of dy over dt in terms of a. Given that the curve has a minimum point when x is equal to 1 over 4, find the value of a. The minimum point is a turning point. So we need to work with the equation for the derivative. In part A, we found that dy over dx is equal to 3 over 2 ax with an exponent of 1 over 2 minus 12. Now, at a stationary point, the equation for the derivative is equal to 0 when x takes on the value of the x coordinate of that turning point. So we can say 3 over 2 multiplied by a. Let's substitute 1 over 4 into x, the exponent of 1 over 2 minus 12 is equal to 0. And now we can solve for a. We can say 3 over 2 a. An exponent of 1 over 2 is a square root, and the square root of 1 over 4 is 1 over 2. You can say 1 over 2, close the bracket, and let's move our 12 to the right. So this becomes equal to 12. Now on the left, I have 3 over 2 multiplied by 1 over 2, which gives me 3 over 4a, and this is equal to 12. To solve for a, let's multiply both sides by 4. 12 multiplied by 4 is 48. Divide both sides by 3, and we get 16. So a is equal to 16. The equation of a curve is y is equal to 4 cos 2x plus 3. State the greatest and least possible values of y. Before we look at the values of y for this equation, let's look at the possible values of y for a simple function of cos x. Cos x has a maximum turning point when y is 1, and say maximum is 1, and the minimum turning point is negative 1. Now let's look at the graph of cos 4 cos 2x plus 3. The value of a and the value of q affect the y coordinates of every point. In terms of transformation, to find the y coordinates, we take the y coordinate of a basic cosine graph, multiply by 4, and add 3. So the maximum value of y for this graph is going to be 1 multiplied by 4, which is 4, plus 3, which gives us 7. For the minimum point, we take the y coordinate of the minimum point of a basic cosine graph, negative 1. We say negative 1 multiplied by 4, which gives us negative 4, plus 3, which is equal to negative 1. So for this graph, the greatest possible value of y is 7, and the least possible value of y is negative 1. Sketch the curve. In part A, we just found the maximum value of y for this curve is 7. So let's put this on our y-axis, and the minimum value is negative 1. The maximum value is 7, so this is our y-intercept. Now, for a basic cosine graph, the interval between maximum turning points is 360 degrees, 2 pi radians. But in this case, we have cos 2x, and the coefficient of x affects the period of the graph. It affects the interval between the maximum turning points. To find the new interval, we divide 2 pi, the original interval, by the coefficient of x, which is 2. These will cancel. So the interval between the maximum turning points is pi. So let's plot our maximum turning points. We have another one at pi 7 and a third one at 2 pi 7. Now let's consider the minimum turning points of this graph. In a basic cosine graph, the minimum turning point sits at 180 degrees, negative 1, which in radians is pi negative 1. The interval is 360 degrees. So we have an interval of 2 pi. But again, here we are working with cos 2x. The coefficient of x affects not only the x-coordinate of each point, but the interval as well. So in this case, we divide the x-coordinate by 2 and the interval by 2. So this becomes pi. From this, we can see we will have a minimum turning point at 1 over 2 pi negative 1 and 3 over 2 pi negative 1. And we can sketch our curve like this. Hence determine the number of solutions of the equation for cos 2x plus 3 is equal to 2x minus 1 for x is greater than 0 but smaller than 2 pi. Let's start by looking at the sketch that we drew in part B. Now, a question like this looks extremely intricate, but it's actually very simple when you understand what it's asking. The question says, determine the number of solutions. A solution is a point of intersection, and it tells us that our cosine graph is equal to 2x minus 1. 2x minus 1 is a straight line. So to solve this question, we need to find the number of times the straight line 2x minus 1 crosses our cosine graph. The straight line takes on equation y is equal to 2x minus 1. And we can see that negative 1 is the y-intercept. We can plot this over here. For a straight line, we need 2 points. So let's substitute 2 pi into x. Let's take our calculator. The equation is 2x minus 1. You can say 2, open a bracket, 2 pi, close the bracket, minus 1 is equal to 11,5. This is the y-coordinate. This is a sketch. It does not have to be to scale. So let's draw our point up here. And now we can sketch our line. Now we can see that the line crosses the graph 1, 2, 3 times. So there are 3 solutions. And as our answer, we can simply say 3. The diagram shows the curve with equation y is equal to 9 over 5x plus 4 with an exponent of 1 over 2, and the line y is equal to 6 minus 3x. The line and the curve intersect at point P, which has y-coordinate 3. Find the area of the shaded region. Now, in this course, we have looked at shaded areas under a curve, areas under a line, and areas between a curve and a line. But in this diagram, we can see that the shaded area lies below the curve up into point P, and then on this side, it lies under the straight line. So we have to find this shaded area in 2 sections. The shaded area starts at the y-axis, where x is 0, but we need to find our other x restrictions. And the first one we need to find is the x-coordinate of P. At P, the curve and the line intersect. So we can use either equation to find the x-coordinate of P. Always use the simpler equation, which in this case is the straight line. The question tells us that at P, y is 3. So we can use this to find x. So we can say 3 is equal to x minus 3x. Our x term needs to be positive, so we get 3x is equal to 6 minus 3. 6 minus 3 is 3. Divided by 3 gives us 1. So x is equal to 1. This is the x-coordinate of point P. So let's put this into our diagram over here. It is our x restriction. Now we need to determine our second x restriction, the x-intercept of the straight line. At the x-intercept, y is 0. So we can say 0 is equal to 6 minus 3x, which means that 3x is equal to 6. Divide by 3 on both sides. So x is equal to 2. This is our other x restriction. Now we can make some space. Let's start by finding the area under the curve. To do this, we need to integrate. Now, it's difficult integrating when you have an x term in the denominator of your fraction. So let's move the bracket to the top, and we can make our exponent negative. So our equation becomes y is equal to 9, open bracket, 5x plus 4, with an exponent of negative 1 over 2. Now, because we have a bracket, we need to use the reverse chain rule to integrate. So let's make the bracket t, and then say t is equal to 5x plus 4. Now I can differentiate, and I can say dt over dx is equal to 5, which means my equation y becomes 9t with an exponent of negative 1 over 2. And now I can integrate, and I get 9t with an exponent of negative 1 over 2 plus 1 becomes positive 1 over 2, all over 1 over 2. Because I'm using the reverse chain rule, I now need to divide by my derivative, which is 5. So I can say divided by 5. 9 divided by 1 over 2 is 9 multiplied by 2. So this becomes 18. T with an exponent of 1 over 2 divided by 5. So let's say over 5. But we are not working with an equation in terms of t. We are working with an equation in terms of x. So we now need to substitute the bracket back into t. And we get 18, the bracket of 5x plus 4 with an exponent of 1 over 2 all over 5. And now we can find the area under the curve between x values of 0 and 1. Let's start with 0. And all you have to do is substitute 0 into x. And we get 18, the bracket of 5 multiplied by 0 plus 4, close the bracket with an exponent of 1 over 2, all over 5. And you can put this straight into your calculator. So we can say 18, open a bracket, 5 multiplied by 0, plus 4, close the bracket with an exponent of 1 over 2, all over 5. And we get 36 over 5. You can write this down over here, 36 over 5. Now we can substitute 1 into the equation. I'm going to say 18, open a bracket, 5 multiplied by 1, plus 4, close the bracket with an exponent of 1 over 2, all over 5. Take my calculator, 18, open a bracket, 5 multiplied by 1, plus 4, close the bracket with an exponent of 1 over 2, all over 5 is equal to 54 over 5. I can say 54 over 5. Now to find the area, all we do is we take the larger value and we subtract the smaller one. So I can take my calculator, 54 over 5 minus 36 over 5 is equal to 18 over 5. I can make a note of this over here. This is the area beneath the curve. Now we need to find the area under the straight line. If I were to draw a line from P down to the x-axis, I've now created a triangle. Specifically, a right angle triangle. So to find this area, I can use the area of a triangle is equal to 1 over 2 multiplied by the base multiplied by the perpendicular height. The base of the triangle is the distance from this point below P, where x is 1, to the x-intercept at 2. 2 minus 1 is 1, so the base is 1. The height is the y-coordinate of P, which is 3, down to the x-axis. So we know that the perpendicular height is equal to 3. So for the area of the triangle, I can say the triangle is equal to 1 over 2 multiplied by 1 multiplied by 3, and I get 3 over 2. This is the area under the triangle. So to find the total area, I can say 3 over 2 plus the shaded area under the curve, 18 over 5. Let's take my calculator. 3 over 2 plus 18 over 5 is equal to 51 over 10. And I can leave this fraction as it is. Prove the identity that tan theta plus 7 over tan squared theta minus 3 is equal to sine theta cos theta plus 7 cos squared theta all over 1 minus 4 cos squared theta. Now we know that tan theta is equal to sine theta over cos theta. So we can try and manipulate the fraction on the left to look like the fraction on the right. Let's start by changing tan theta into sine theta over cos theta. So I'm going to say sine theta over cos theta plus 7 all over tan squared theta becomes sine squared theta over cos squared theta minus 3. Now we have not only two terms in both our numerator and our denominator, but we have fractions within fractions, and this can become very complicated. So let's turn the numerator and denominator into individual fractions. So for our numerator, we're going to have sine theta plus 7. We're giving 7 a denominator of cos theta. And if you give a value a denominator, you have to give the numerator the same value. So this becomes 7 cos theta all over cos theta. Now for our denominator, we have sine squared theta minus 3 cos squared theta all over cos squared theta. When you are working with a fraction, we're actually dividing the numerator by the denominator. And we know that if you are dividing fractions, you can tip in times. So now we can say sine theta plus 7 cos theta over cos theta multiplied by, let's tip the bottom fraction, we get cos squared theta over sine squared theta minus 3 cos squared theta. And now we can cross cancel. But the numerator over here and the denominator over here include two terms that are not the same, so we cannot cancel. But we have a cosine down here in the denominator and cosine squared up here. So the cosine will cancel with the square. And now we have sine theta plus 7 cos theta. Let's put this into a bracket, multiplied by cos theta over sine squared theta minus 3 cosine squared theta. Now we can expand the bracket in the numerator. I'm going to make some space. And we're going to get sine theta cos theta plus 7 cos squared theta over sine squared theta minus 3 cos squared theta. The numerator is now the same as the numerator of the fraction on the right. So all we need to do is manipulate the denominator. In this fraction, we have a denominator with a cosine ratio only. So we need to get rid of sine squared theta. We know that cos squared theta plus sine squared theta is equal to 1, which means that sine squared theta is equal to 1 minus cos squared theta. So now, in our numerator, we have sine theta cos theta plus 7 cos squared theta all over. Instead of sine squared theta, I'm going to use 1 minus cos squared theta. So 1 minus cos squared theta minus 3 cos squared theta. And now I can tidy up like terms. So my numerator, sine theta cos theta plus 7 cos squared theta all over 1 minus cos squared theta minus 3 cos squared theta gives me negative 4 cos squared theta. And now we have the fraction on the right. So we can say that this is now equal to the right hand side. Part B says hence solve the equation. But in these fractions, we've got sine theta, cos theta, and tan theta. And it is very, very difficult to solve for theta if we have more than one kind of trigonometric ratio. But in part A, we have just found that this fraction over here is equal to tan theta plus 7 over tan squared theta minus 3. So let's use this. So we can say tan theta plus 7 over tan squared theta minus 3 is equal to 5 over tan theta. Now we only have one trigonometric ratio, so we can find the values of theta. Let's start by multiplying out our denominators. And we get tan theta multiplied by tan theta plus 7 is equal to 5 tan squared theta minus 3. And now we can close the bracket. Now we can expand and we get tan squared theta plus 7 tan theta is equal to 5 tan squared theta minus 15. Now we have a quadratic. We have tan squared over here and 5 tan squared on this side. So let's move all of our terms to the right. So I'm going to have 5 tan squared theta minus 15. Move tan squared, I get minus tan squared theta minus 7 tan theta. And this is now equal to 0. Now we can add like terms. 5 tan squared minus tan squared gives us 4 tan squared theta minus 7 tan theta minus 15 is equal to 0. Now we have a quadratic with tan theta, and many students battle working with quadratics with trigonometric ratios. So to make it easier, let's substitute x into our tan ratio. So I'm going to say let tan x, in this case tan theta, equal x. Now I can make some space, and my equation becomes 4x squared minus 7x minus 15 is equal to 0. Now let's use the quadratic formula to solve for x. So I can say x is equal to negative b. b is negative 7, so negative b becomes positive 7, plus or minus negative b, negative 7 squared, minus 4, multiplied by a, which is 4, multiplied by c, which is negative 15. Close the bracket, all under a root, all over 2 multiplied by a, which is 4. 2 multiplied by 4 gives us 8. Now we can take our calculator and find the values under the root. I have negative 7 squared, so let's open a bracket, negative 7 squared minus 4 multiplied by 4 multiplied by negative 15, close the bracket, is equal to 289. Let's square root, and we get 17, which means that x is now equal to 7 plus or minus 17 all over 8. Let's find my positive value of x. So I can say 7 plus 17 divided by 8 is equal to 3. So x could be equal to 3. Now let's find my negative x. So I can say 7 minus 17 divided by 8 is equal to negative 5 over 4. So x could be equal to negative 5 over 4. But remember that I'm not solving for x, I'm solving for theta. So let's put the tan ratio back into our equation, and we get tan theta is equal to 3, or tan theta is equal to negative 5 over 4. Now I can find theta. The question gives us theta in degrees, so make sure that your calculator is in degrees. So when tan theta is equal to 3, I can say shift tan 3, close the bracket, is equal to 71,565. To round that to 2 decimal places, so theta is equal to 71,56 degrees. Now let's find theta for negative 5 over 4. So I can say shift tan negative 5 over 4, close the bracket, is equal to negative 51,34. Theta is equal to negative 51,34 degrees. But remember that your calculator will only give you angles between negative and positive 90 degrees. But this question is asking us to find angles between 0 and 180 degrees. So let's make some space, and we can make a note of our values for theta. The easiest way to find other values given our domain is to draw a quick sketch. We are considering values of theta between 0 and 180 degrees. So let's put in our x and y axes. we know we have an asymptote at 90 degrees, and I can sketch my trigonometric graph like this. But one of my values of theta is negative 51,4 degrees. So I am going to include part of my graph for negative degrees as well. The first value of theta that we found is 71,57 degrees, and that will sit around about here. Now I can draw a red line through my point, and this line does not touch my graph anywhere else. So there are no other values of theta that I need to consider for this point. So let's look at theta when it's negative 51,34 degrees, and that will sit to the left of the x-axis down here. Let's draw a line, and the line touches the graph again. So let's make this point red as well. I cannot consider this point because it is outside of my domain. But now I have a second point between 0 and 180 degrees, and I have to consider this value of theta. My original point lies 51,34 degrees to the left of 0, which means my new point lies 51,34 degrees to the left of 180. So let's take my calculator, and I can say 180 minus 51,34 is equal to 128,66. This is a value of theta I need to consider. So I can say theta is equal to 128,66 degrees. And don't forget our original point. Theta is equal to 71,57 degrees. The diagram shows the circle with the equation x squared plus y squared minus 14x plus 8y plus 36 is equal to 0, and the line y is equal to negative 2. The line intersects the circle at the points A and B. The center of the circle is C. Part A says find coordinates of A, B, and C. Let's start with the center C, because we can find these coordinates from the equation of the circle. The coefficient of x gives us the x coordinate of the center. We have negative 14. To find the x coordinate, divide by 2 gives us negative 7, and change the sign, which gives us positive 7. The coefficient of y gives us the y coordinate. We have 8. Divided by 2 gives us 4. Change the sign, and we get negative 4. These are the coordinates of the center C. So let's put them into the diagram. The question tells us that the line y is equal to negative 2 intersects the circle at points A and B. This means that A and B both have a y coordinate of negative 2. You can put this up here and over there. And all we need to do is find the respective x coordinates. So we can substitute negative 2 into the y values for the equation for the circle so that we can solve for x. So we can say x squared plus, instead of y, let's say negative 2 squared minus 14x plus 8 multiplied by negative 2 plus 36 is equal to 0. Now we have x squared plus 4 minus 14x minus 16 plus 36 is equal to 0. Now we can add like terms. I'm going to write up here, we have x squared minus 14x 4 minus 16 gives us negative 12, plus 36 gives us 24. Say plus 24 is equal to 0. In order to solve for x, you can use the quadratic formula or you can factorize. In this case, I'm going to factorize. So I have two brackets with x terms. My constant is 24 and the coefficient of x is negative 14. Let's consider 2 and 12. 24 is positive, but 14 is negative. So we have x minus 2 and x minus 12, which means that x could be equal to 2 or it could be equal to 12. Now point A lies closer to the y-axis, which means it has the smaller value of x. So point A has coordinates of 2, negative 2. B lies further away, so its x-coordinate is 12. And we now have the coordinates of A, B, and C. Find the angle ACB in radians. Give your answer correct to 3 significant figures. Now, to tackle a question like this, we can use the tangent ratio because tan theta gives us the gradient of a straight line, M. As long as theta is an acute angle that lies between a horizontal line and a straight line. So theta will be over here. Now in part A, we found the coordinates of points A, B, and C. So let's put them into the diagram. And I'm going to draw a straight horizontal line through point C. A horizontal line has an angle of 180 degrees, pi radians. So let's start by finding the gradient of line BC. B has coordinates 12, negative 2, and C has coordinates 7, negative 4. Let's say that B is our first point and C is our second. So I can say the gradient of BC is equal to negative 4 minus negative 2 over 7 minus 12, which gives me negative 2 over negative 5. The negatives will cancel out, and I get 2 over 5. To find the angle, this acute angle over here, I can say that tan theta is equal to 2 over 5. And now I can take my calculator and I can say shift tan 2 over 5, close the bracket, is equal to 0,38 radians. This is the acute angle. So I can put this into my diagram over here. Now let's find an angle for AC. So let's draw in AC. A takes on the coordinates 2, negative 2, and C, 7, negative 4. So for the gradient of AC, I can say negative 4 minus negative 2 over 7 minus 2 is equal to negative 2 over 5. So to find the acute angle, this one here, I can say tan theta is equal to negative 2 over 5. Take my calculator, shift tan, negative 2 over 5, close the bracket, is equal to negative 0,38. Now, the reason why the angle is negative is because the gradient of the line is negative, but this is still an acute angle. So this angle is also 0,38 radians. Now, we just said that the line drawn through C is a straight line. of 180 degrees, pi radians. So to find angle ACB, this one over here, all we have to do is say pi radians minus angle at BC, this one, 0.38, minus this acute angle, 0.38, is equal to, now I can take my calculator and I can say pi minus 0.38 minus another 0.38 is equal to 2,3815 and so on. The question tells us to give our answer correct to 3 significant figures. So the angle of ACB must be 2,38 radians. The chord AB divides the circle into 2 segments. Find the area of the larger segment. Now, even though we've been working with coordinate geometry on the Cartesian plane, we are now working with circular measure. And in circular measure, we have looked at the area of a sector, the area of a triangle, and the area of a minor segment. We cannot find the area of a larger sector directly. But in part B, we just looked at the angle of ACB. And now we have a major sector. And we found the angle to be 2,38 radians. We also have triangle ABC. And if we take the area of the major sector and the triangle, we will get the area of the larger segment. So let's start with the area of the major sector. To find the area of a major sector, we need the radius and the angle. In part A, we found the coordinates of A, B, and C. So let's put these back and down here. AC is the radius of the circle. For the equation of a sector, we need 1/2 r squared theta, where r is the radius. AC is our radius. So let's find AC squared. To find the length of AC, we can use the formula for distance. AC squared is equal to y2 minus y1 squared plus x2 minus x1 squared. Because we are looking for r squared, AC squared, we don't need to put this formula under a root. Let's say that A is our first point and C is our second. So we can say AC squared is equal to -4 minus -2 squared plus 7 minus 2 squared. -4 plus 2 is -2 square, and we get 4, plus 7 minus 2 is 5, square that, and we get 25. So AC squared has to be 29. Now that we have R, we need the size of our angle. But because we are looking at the major sector, we need to use this angle over here. We know that the sum of the angles around any point is 360 degrees, 2 pi radians. And if we know that ACB is 2,38 radians, then this angle has to be 2 pi, I'm going to put it down here, 2 pi minus 2,38 radians. And now we have enough information to find the size of the major sector. So we can say the area of the major sector, area, is equal to 1 over 2 multiplied by r squared, which is 29, multiplied by the angle, 2 pi, minus 2,38. And you can put all of this into your calculator. And we can say 1 over 2 multiplied by 29 multiplied by 2 pi minus 2,38, close the bracket, is equal to 56,59. Let's round this off to 1 decimal place, and the area of the major sector is 56,6. Now, to find the area of the whole segment, we still need the area of triangle ABC. So let's make some space. We are working with circular measure, but this is still on the Cartesian plane, which means we can use the coordinates of A, B, and C to help us find the area of this triangle. So we can use the formula 1 over 2 times base times perpendicular height. Let's let AB be the base of the triangle. A has coordinates 2, -2, and B 12, -2. The length of the base is the distance between AB along the x-axis. So I can say the base is equal to 12 minus 2, which equals 10. For the height, we need to look at the distance between the line AB and the coordinate of C along the y-axis. So we can say the height is equal to -2 minus -4, which gives us 2. Now we've got enough information to find the area of the triangle. You can say the triangle is equal to 1 over 2 multiplied by the base, which is 10, multiplied by 2, which gives us an area of 10 units. Now we have the area of the triangle and we have the area of the major sector. Let's say plus 56,6, which means the total area of the larger segment has to be 66,6 units. The equation of a curve is such that d squared y over dx squared is equal to -24 over x cubed. It is given that the curve has a stationary point at -2, 19. Part A says find an expression for dy over dx. The question gives us the equation of the second derivative and asks us to find an expression for the first, so we need to integrate. But it is always more difficult to integrate equations where you have your x variable in the denominator of a fraction. So the first thing I want to do is I'm going to rewrite d squared y over dx squared as -24 x with an exponent of -3. And now I can integrate. So I'm going to say dy over dx is equal to -24 x with an exponent of -3 plus 1 gives me -2 all over -2. Now the negatives will cancel. 24 divided by 2 is 12. So this becomes 12 x with an exponent of -2 plus c. The question also tells us that the curve has a stationary point at -2, 19. This means that the equation for the derivative, this one over here, is equal to 0 when x is -2. And I'm going to use this to find the value for c. So I'm going to say 12. Instead of x, we put in -2 with an exponent of -2 plus c is equal to 0. Now I can take my calculator and I can say 12 multiplied by -2 with an exponent of -2 is equal to 3. So 3 plus c is equal to 0, which means that c is equal to -3. This means that the equation for dy over dx is equal to 12x with an exponent of -2 minus 3. Part B says find the x-coordinate of the other stationary point of the curve and determine the nature of this stationary point. Now in part A, we just found that the equation for the derivative dy over dx is 12x with an exponent of -2 minus 3. And at a stationary point, this equation is equal to 0. We can make this equal to 0. And now I can solve for x. To solve for x, I'm going to turn x with an exponent of -2 back into the denominator of the fraction. So I have 12 over x squared. Let's move 3 to the right, and this is equal to 3. To get x by itself, let's multiply both sides by x squared, and I get x squared on the right. Divide by 3, 12 over 3. 12 over 3 is 4, and this is equal to x squared. To get x by itself, let's square root both sides, and we can see that positive or -2 is equal to x. Now, the question tells us that the curve has a stationary point when x is -2, which means that the x-coordinate of the other stationary point has to be 2. So over here, I'm going to say x is equal to 2. The question asks us to determine the nature of the stationary point. The nature means whether or not the point is the maximum or minimum turning point. And to determine the nature, we need to substitute 2 into the equation of the second derivative, which we've been given in the question. So I can say -24. Instead of x, I'm going to say 2 cubed is equal to, let's take the calculator. I have -24 divided by 2 cubed is equal to -3. The second derivative is equal to -3. -3 is smaller than 0, which means that this has to be our maximum turning point. Part C asks us to find the equation of the original curve. Now in part A, we found the equation of the derivative dy over dx is equal to 12x with an exponent of -2 minus 3. To find the equation of the curve y, we need to integrate this equation. So we can say y is equal to 12 with an exponent of -2 plus 1 gives us -1 over -1. Our constant becomes our x term. It becomes minus 3x plus c. Now we can tidy this up and we get -12 x with an exponent of -1 minus 3x plus c. We need the value of c. The question tells us that the curve has a stationary point with coordinates -2, 19. This means that when x is -2, y is 19. And we can use this to find the value of c. So I'm going to say 19 is equal to negative 12 multiplied by negative 2 with an exponent of negative 1 minus 3 multiplied by negative 2 plus c. Now I can take my calculator. I'm going to say negative 12 multiplied by negative 2 with an exponent of negative 1 is equal to 6. So this becomes 6. Negative 3 multiplied by negative 2 is positive 6. That's a plus 6 plus c. And this is equal to 19. 6 plus 6 is 12. 19 minus 12 gives me 7. So over here, I'm going to say c is equal to 7. Now we can write our equation for y. Y is equal to negative 12, x with an exponent of negative 1, minus 3x plus 7. For part D, we need to find the equation of the normal to the curve at the point where dy over dx is equal to negative 9 over 4 and x is positive. Express your answer in the form px plus qy plus r is equal to 0, where p, q, and r are integers. Now, a normal is a straight line, and to find the equation of a straight line, we need the gradient and 1 point. Remember that the normal is perpendicular to the curve at a specific point. And the question tells us that the gradient of the curve at this point is negative 9 over 4. So to find the perpendicular gradient, all we have to do is flip the fraction upside down and change the sign. So we can see that the gradient of the normal is going to be positive 4 over 9. And now we need the x and the y coordinates of this point. We are given information about dy over dx, so we can use this to find our value of the x coordinate of this point. In part A, we found the equation for the derivative to be 12, x with an exponent of negative 2. I'm going to turn this back into a fraction, 12 over x squared minus 3. And the question tells us at this point, the derivative is equal to negative 9 over 4. So we can make our equation equal to negative 9 over 4. And we're going to use this to solve for x. So let's say 12 over x squared. Let's move 3 to the right. Negative 9 over 4 plus 3 gives us positive 3 over 4. Now to get x squared by itself, let's multiply both sides by x squared. On this side I'm going to have 3x squared is equal to 12 multiplied by 4, which is 48. Let's divide 48 by 3, and I get 16, which is equal to x squared. Square root both sides, and 4 is equal to x. The question tells us that x is positive, so 4 is x because we have to consider the positive root. Now that we have the x coordinate of our point, we need the y coordinate. So we need to use the equation for the curve, which we found in part C. Y is equal to negative 12 over x minus 3x plus 7. And to find y, we can substitute 4 into x. Y is equal to negative 12 over 4 minus 3 multiplied by 4 plus 7. Negative 12 over 4 is negative 3 minus 12 plus 7, and we get negative 8. So the coordinates of the point will be 4, negative 8. Now we can make some space. Our coordinates for our point are 4, negative 8, and the gradient of the normal is 4 over 9. The normal is a straight line, so we're going to use the equation y is equal to mx plus c. We need the value of c, so let's input our known values. The y-coordinate is negative 8, so we have negative 8 is equal to m, 4 over 9, multiplied by x, which is 4, plus c. Now we have negative 8 is equal to 16 over 9 plus c, which means that negative 8 minus 16 over 9 is equal to c. Let's take our calculator and we say negative 8 minus 16 over 9 is equal to negative 88 over 9. So negative 88 over 9 is equal to c. And now we can write our equation for the normal in the form y is equal to mx plus c. So we said y is equal to 4 over 9 x plus c, which is negative 88 over 9. But the question wants our answer in the form px plus qxy plus r is equal to 0. In this form, our constant and our coefficient cannot have a fraction. So the first thing we need to do is multiply out the denominator of 9. It's going to get 9y is equal to 4x minus 88. The question wants all of our terms on one side of the equal sign, and you can decide which side you want to move them to. I'm going to move 9y to the right. So the equation becomes 4x minus 9y minus 88 is equal to 0. This is the equation for our normal. The first, second, and third terms of an arithmetic progression are 4k, k squared, and 8k respectively, where k is a non-zero constant. Find the value of k. We are working with an arithmetic progression, and these progressions have got a constant difference. So let's start by writing our three terms across the page. We have 4k, that's term 1, k squared is term 2, and 8k is term 3. The difference is constant. That means that k squared, our second term, minus 4k, our first term, has to be the same as the difference between our second and third terms, 8k minus k squared. And now we've got an equation that we can use to solve for k. We have a quadratic, so let's move all of our terms to the left. We have k squared minus 4k minus 8k plus k squared, and this is equal to 0. K squared plus k squared gives us 2k squared. Negative 4 minus 8 is negative 12k, and this is equal to 0. Both of our terms are even, so let's divide both by 2, and we're left with k squared minus 6k is equal to 0. Now I can take k out as a common factor. I get k multiplied by k minus 6 is equal to 0, which means that k is equal to 0, or k is equal to 6. But the question tells us that k is a non zero constant, which means k cannot equal 0 and k has to be equal to 6. Find the sum of the first 20 terms of the progression. Now, to find the sum of terms in arithmetic progression, we use the formula Sn is equal to n over 2, open a bracket, 2a plus n minus 1 d. We are looking for the sum of 20 terms, so n is 20. We need a value for a and for d. In part 1, we found that k is 6, and the question tells us that our first term, a, is 4k. So I can say a is equal to 4 multiplied by k, which is 6, which gives me 24. Now I need the constant difference d. D remains constant between any sets of consecutive terms. So to find d, let's find the value of the second term, k squared. So I could say t2 is equal to, k is 6, so I have 6 squared, which is equal to 36. To find d, I can say 36 minus 24 is equal to 12. Now I have a value for n, a value for a, and a value for d. So my equation becomes the sum of 20 terms is equal to, n is 20, 20 divided by 2 gives me 10, open a bracket, 2 multiplied by a, which is 24, plus, open a bracket, n is 20, 20 minus 1 is 19, multiplied by d, which is 12, and we can close the bracket. Now I can take my calculator. I can say 2 multiplied by 24 plus 19 multiplied by 12 is equal to 276. Let's multiply that by 10 is equal to 2,760. The fourth and sixth terms of a geometric progression are 36 and 6 respectively. The common ratio of the progression is positive. Find the sum to infinity of the progression. Give your answer in the form a over root b minus c, where a, b, and c are integers. To find the sum to infinity, we use the formula sum to infinity is equal to a over 1 minus r. So to find this value, we need a value for a and a value for r. Now, the question tells us that the fourth term is 36 and the sixth term is 6. And we know that if we take the fourth term in a geometric progression and we multiply by r, we get the fifth term, multiply by r again, and we get the sixth term. The fourth term is 36, multiplied by r again, which means we multiply by r squared, is going to be equal to 6. And now we can find the value of r. So we can say r squared is equal to 6 over 36. Simplify, and we get 1 over 6. The question tells us that the common ratio, r, is positive. So to find the value of r, we only need to consider the positive root. So if r squared is 1 over 6, then r is equal to the square root of 1, which is 1, over the square root of 6. So we can leave this as the square root of 6. With the value of r, we can now find the value of a. A is our first term. If we multiply by r, we get the second term. Multiply by r, we get the third term. Multiply by r again, we get the fourth term. The fourth term is 36. which means that a multiplied by r cubed is equal to 36. And we can use this to find the value of a. So we can say a is equal to 36 over r, 1 over root 6 cubed. Let's put this into a bracket, cubed. Now I can take my calculator and I can say 36 over, open a bracket, 1 over root 6, close the bracket, cubed, is equal to 529,0897844. The problem with using your calculator for this question is that the question tells us that a, b, and c are integers, and we now have an a value with too many decimals. So a better idea is to leave it in this format. Let's see if we can tidy it up a little bit. We have 36 over 1 cubed, which is 1, over root 6 cubed. We have a fraction within a fraction, so this becomes 36 divided by 1 multiplied by root 6 cubed, and we can get an a value of 36 multiplied by root 6 cubed. Let's leave this in this format for now, and now we can make some space. For the sum to infinity, we can say the sum to infinity is equal to 36 multiplied by the square root of 6 cubed, all over 1 minus r, which I now know is 1 over the square root of 6. But the question tells us that we have to leave our answer in the form a over root b minus c, where a, b, and c are integers. We cannot have fractions, so we need to tidy up the denominator of this fraction. So I'm going to rewrite the denominator over here, 1 minus 1 over root 6. If you have a square root in the denominator of a fraction, we need to rationalize the denominator. And to do that, we need to multiply by a fraction that has this value in both its numerator and denominator. In this case, let's put this into a bracket, and we're going to multiply by the fraction root 6 over root 6. The numerator and denominator of this fraction have the same value, which means that this fraction is equal to 1. So our value is actually not changing. Now we can multiply this out. 1 multiplied by root 6 over root 6 gives us root 6 over root 6 minus 1 over root 6 multiplied by root 6 over root 6. These will cancel, and we get 1 over root 6. Now I have two fractions with the same denominator, so I can rewrite this as root 6 minus 1 over root 6. This is going to be the denominator over here. So to save space, I'm going to erase my original denominator, and I'm going to rewrite in root 6 minus 1 over root 6. Remember that when you have a fraction, we are actually dividing the numerator by the denominator. So we can rewrite this as 36 root 6 cubed divided by root 6 minus 1 over root 6. And when you are dividing fractions, we tip in times. So we get 36 root 6 cubed multiplied by root 6 over root 6 minus 1. Let's quickly make some space. Now this equation becomes 36 multiplied by root 6 cubed multiplied by root 6 all over root 6 minus 1. Now our denominator looks like the denominator in the form that the question wants. So all we need to do is tidy up a. Let's take our calculator and we're going to say 36 multiplied by, let's open a bracket, root 6, close the bracket, cubed multiplied by root 6 is equal to 1,296. Now a is an integer as well. So I can say 1,296 over root 6 minus 1. Express x squared plus 4x plus 2 in the form x plus a squared plus b. Now, when you see the form with a bracket squared plus a constant, this is completed square form, which in most of your textbooks may look like x plus p squared plus q. Regardless of the letters A, B that you see in the question, it could be anything, P, Q, S, T, M, and N. If you see the form like this, we are working with completed square form. And to find P, we can use the formula P is equal to B over 2A, and Q is equal to C minus AP squared. A is the coefficient of the squared term in the trinomial, B is the coefficient of x, and C is the constant. So in this case, I can say P is equal to B, the coefficient of x, 4 over 2 multiplied by 1, which is simply 2. 4 divided by 2 gives me 2. This is my P value. Now to find Q, I can say Q is equal to the constant C, which is 2, minus A, the coefficient of the square term, which is 1, multiplied by P, which I just found, 2 squared. And I get 2. 2 squared gives me 4, multiplied by 1 stays as 4. I get 2 minus 4, which is equal to negative 2. So now, in this form, I can rewrite my expression, open a bracket, x plus a, which in this case is 2, squared minus 2. Find an expression for f to the negative 1x, which is the inverse of x. When finding for the equation for the inverse, it is always easier if the equation for the original function is in completed square form. So in part A, we just found this equation. So let's rewrite f of x is equal to x plus 2, close the bracket, squared, minus 2. Now we can turn f of x into y. Let's say y is equal to x plus 2 squared minus 2. To find the inverse, we need to swap our x and y variables. You can say x is equal to y plus 2, close the bracket, squared, minus 2. And now we can rearrange this equation and make y the subject. Let's move negative 2 to the left, and we get x plus 2 is equal to y plus 2 in a bracket squared. To get y by itself, we have to get rid of the squared bracket. So let's square root, which means we square root this side as well. Now we have x plus 2 under a square root is equal to y plus 2. To get y by itself, let's move 2 to the left. And we get x plus 2 under a square root minus 2. This is equal to y. But in this question, the question asks us to leave our format with f to the negative 1x. So I can say f to the negative 1x is equal to, and this is the equation for the inverse function. Find an expression for gf to the negative 1x. Please be very careful with questions like these. You need to pay close attention to where the brackets lie. Here, the bracket is around g and f. This means that we need to find the inverse function of the composite function g f of x. Because we need to find the inverse function, it is a good idea to use f of x in completed square form. So let's make a note that f of x, we found the equation in part A, is equal to x plus 2, close the bracket, squared, minus 2. Now to find the composite function g f of x, we substitute the entire equation for f of x into the x value in g. So I can say g f of x is equal to, I have negative x, so I say negative, open a bracket, x plus 2, close the bracket, squared, minus 2, close my big bracket, minus 4. Now I can tidy this up, and I get negative x plus 2 squared minus negative 2 becomes plus 2 minus 4. Let's add like terms, and I get negative bracket of x plus 2 squared plus 2 minus 4, which is negative 2. And this is the equation for the composite function g f of x. Now I can use this to find the inverse. Let's start by making y the subject. And I'm going to rewrite this as y is equal to negative, open a bracket, x plus 2, close the bracket, squared, minus 2. To find the inverse, I need to swap my x and y variables around. So this becomes x is equal to negative, open a bracket, y plus 2, close the bracket, squared, minus 2. Now to find the equation for the inverse, I need to make this y the subject. And to get y by itself, I need the whole bracket to be positive. So let's move it to the right. And we have the bracket of y plus 2 squared is equal to, let's move x to the right, I get negative x minus 2. To get y by itself, I need to square root this whole bracket, which means I square root all the terms on the right. On the left, the root and the square will cancel. I have y plus 2 is equal to negative x minus 2 under a square root. But remember that when you square root any value, we have to consider both the positive and negative root. Let's finish this up. We now have y is equal to the positive or negative root of negative x minus 2 under a square root minus 2. But when you are working with an inverse function or the equation of any function, we cannot consider both the positive and negative roots, we need to choose one. Remember that the domain of the original function shows us the range of the inverse. In this question, f of x considers x values smaller than or equal to -2. G of x considers x values greater than or equal to -2. These -2's show us the range of the inverse. So in this case, our range considers negative values. And as our final answer, we can say g, f in a bracket, an exponent of -1, x, is equal to the negative root, negative x minus 2 under a square root minus 2.